What's up everyone? Welcome to another videos of this series, Diffuse Architecture Overview, and today we're going to use the whiteboard. In this video we're going to cover, actually not just the whiteboard, but the bstream package. And the bstream package is a low-level component of the platform, the Diffuse platform. This one is going to be a little deep, a little more technical. I mean, feel free to skip to the next video if you find this is, it's more underpinning, but it might be useful for understanding, the breadth and depth of the Diffuse platform. I think it's a very nice piece, and it's been rewritten 3-4 times. There's a lot of wisdom and insight in there. So, okay, let's get it on. I'm going to show here a small sample of that thing being used, and we're going to dive into EOSWUS. If you notice, Diffuse EOS, that's the repository, Diffuse EOSIO, and then in the EOSWUS repository, this is a system that manages the WebSocket. And in this little piece of code we're looking at, it's handling the get action traces call, and we're going to slowly build the thing I've designed here and see how these things get inside together. Okay? I want to start just a second by showing you the interface. What does it mean to be bstream? This is the bstream repository here on GitHub, and the interface that is provided looks like this. This is the building block of the Diffuse platform in a way that is very similar to those middleware systems you have everywhere in every programming language. Often in the web stack you have an incoming request. You can put a middleware, it's therefore, and then gonna call your handler, right? You can create trees, routers, and all sorts of components. We're using the same sort of thing, very similar to those who are knowledgeable about Go, the net HTTP library. But in this case, what's going through is blocks. Block information in the format that we've listed in the previous video. You can watch it up here. And they are in native Go, and they can attach, with that little thing here, you can attach information. For example, you could attach, in the case of the search engine, you'll have an index of the content of that block ready to be queried. Or you can bring about, other information about the block. As it goes and flows through the pipe, you can sort of build some objects. They come through. And the block object in here is, the protobuf object, protobuf scaffolded object. Okay? So I want to introduce a few components that are in there that are building blocks for the whole platform. The first one is the file source. The file source, you provide one with a storage location based on dstore, which we've seen in the previous video, and it's going to start feeding blocks, unpacking them, and then feeding them down the pipe. Okay? Simple, turn around, give it a starting block, and it's going to start just flowing. You don't have a guarantee of which block is going to start. Like if you ask for block, 75, it's rounded to the block 0, and then you're going to have those 75 because the file needs to be read anyway. It's going to be piped through. Maybe you want to have a gate, which we'll see right after, to say I don't want to pass through blocks unless it's that ID or it's above that block number. Okay, and we can craft that. And that's what happens in this design in the example we'll show. But just the lower level things is then the live source. The live source, you remember in the MindReader videos, you turn around, you have a gRPC server called with block stream, interface. And if you call that, it's going to get live blocks. They arrive in the same way. It's a protobuf block, and then you can start feeding that to someone who needs it. But most of the time, what you'll want is something to say, okay, start at block 10 million. And in that case, and if your live node is at 100 million, then you'll need to turn to file source and then stream everything. That's the joining source. You give it a file source factory and a live source factory, and it's going to then transparently pass from one to the other and understand, it's going to try the live source. If it's too far, it's going to stop it and all that. So you get one stream, wherever is the source, it's going to join them together and feed you an extremely fast series of streams of blocks. And you can also, parallelize the file source downloading so that they all arrive and unpack in parallel, so they stream like crazy. It's pretty fun. The other thing here I wanted to introduce is the subscription hub. The subscription hub is a simple in-process fan-out system, like similar to the relayer we'll see later, but it connects on one side to what we'll call an internal source. Somehow it gets blocks, okay, from whatever, and then it offers that as a live source locally. So if you have 75 WebSocket connections, you don't connect 75 times to the network. You'll get one from the network, and the rest is just going to be fanned out from internally. It's a local hub for internal in-go process subscription, and you get a block, and then everyone's listening on that thing will get a copy of the block, not a copy, it's just actually a reference, and then can filter it according to their needs, and then send it through WebSocket, which is what we're going to see right now. Okay, and I'm going to show you the forkable right after. I'm in the action here, the function called when we say get action traces through the WebSocket. You can see in our docs, and then we're going to do a few manglings, and we're creating the handler here. What's going to happen when a block flows in? Now that's the handler we're going to keep at the end. And we're going to get the block, we're going to get a native block for EOS, and we're going to filter through it. If it's not executed, we don't want to filter it. We're going through all the actions. If it's the right receiver, if it's the right account that you're matching, it's just as filtering. And then we're converting that to something that makes sense for you before we actually output it to the WebSocket stream, right? And if you asked for, I want DB operations, we're going to add that to the outgoing data stream, and then it's sent through the WebSocket. So that's just a simple handler. This actually represents this box here, where you're actually receiving whatever, and it's going to be configured after, and you're going to filter according to your needs, and this is the end of the sort of the stream. You're responding through WebSocket. It doesn't have another handler lower than that, right? But before that, as you'll see, we'll have a gate, because maybe we want to start at a given place. See this one here. Let me show you that here. So you want to have a gate because the user requested to start at a given block height. So you don't want to send anything before he asked at this point. So you put a gate. So whatever, if you're receiving from a file source or whatever, you make sure from your perspective that it's gated and it's configured with the user's demand, right? The gate that we see here. But also before that, if you've asked with progress, this is an option in the WebSocket stream, we'll actually decorate. We're going to create another handler, and we're going to replace our handler. It's actually going to insert optionally, let me show you here, optionally a box, right? It's going to say whoop like that and like that, and this is going to be the progress handler. And this one, what it does, well, it has a reference to the WebSocket stream, and when it sees blocks flowing through, independent of filtering, which happened after, it'll say, I've seen block XYZ, and it's going to send periodically messages through the WebSocket again, so it's on the side. So it's decorating and creating sort of a pipe, configured pipe. And what we're not seeing, so same thing here. If we're wanting the irreversible, we'll add a handler, and again replace our handler with the decorated. We're passing our current handler, current configured. We're adding a new box here, here, in these lines. If we ask for irreversible only, then the forkable is going to be put there with a filter of irreversible on. I'm going to give you a sample of the forkable right after. And then we replace our handler, therefore configuring, another box in between here, saying, okay, this is IRR only, and then we link back to filter. So we don't even lose time filtering things that are not irreversible, and we stitch things together like that. And now we see, if we look in the code again, we start from the subscription hub to get something that we configure. We give it a block gate. This is target joining thing. And in this one, this source, we'll actually ask for the irreversible block at the beginning, asking to start at this block so that we can have all the data we need to have a reversible segment and navigate the forks, navigate the reorganizations of the chain. So that's why you have those two boundaries. And then what we do, we simply kickstart the source here. So registered, whatever, this is just, we're sending a small message saying we're listening, and we kickstart the source. And from that point on, well, the blocks are going to flow from here to there, all through, filter, and pipe that to the message. So this is the way it's laid out, right? It's fun. It's building blocks, and they're each very isolated in their purpose. They can be composed very well. So I appreciate that. And one other thing about the subscription hub, which I can show you also here, the subscription hub itself has a quite complex handler. So this is how we launch the subscription hub. Over here, where you see we're in the bstream hub, and we have a series of subscribers down there, and we have a factory for file source and a factory for live source. So we know how to kickstart that. It'll be sort of pre-configured with the location of the blob storage and whatever, and the IP address of the service, the gRPC service. So it can always start with new parameters. In here, you'll see that we're configuring some wonky things with the the source from reference factory, and then we'll have, a block gate, and it gets, it needs to be very precise. So we have a file source factory, and these are passed to the joining source because it starts with a factory, and then we wrap all of that in an eternal source. And what that means is that this thing is never gonna stop. And it's going to have all the guarantees so that it always continues on from where it left off, even though there's network disconnection, even though it's waiting for files, even though there's no live source. It's going to then watch only files and retry the live, and but the eternal source is always going to never let you down somehow. And then at this point, you get that guarantee, right? By all these things behind the scene, the sub is always going to continue. And all of the streams that are waiting, and the WebSocket streams that are waiting, are going to be fed eventually when things settle up again. Okay? So this first part was about the first part of bstream. On the next series, on the next video, I'll introduce the forkable and forkdb, which are other features of bstream. Feel free to skip these if you want to go to the higher level stuff. Now you can imagine that all of our systems use that. They're all composed like that. The search indexer has this configured thing like that with the different guarantees of every component. This builds an index, and so EOSWUS, anything that feeds block is built using that infrastructure. So in the next video, we will see the forkable and the forkdb implementation that lives inside bstream, and also later on, we'll see about high availability and topology. Okay, so hope this is helpful. If you have comments, please don't hesitate to go in the channel and start that repo. Hey, thank you.